Question says a body performing SHM, then average total energy per cycle is equal to its maximum kinetic energy. Average kinetic energy per cycle is equal to half of its maximum kinetic energy, and root mean square velocity is 1 by root 2 times of its maximum velocity. So we have this. So this question is from simple harmonic motion. So let us solve this question. For simple harmonic motion SHM, we take the displacement from the mean position y. Y is the displacement from the mean position, and for SHM, y can be written as a cos omega t. This is the displacement from mean position. Here is the amplitude of oscillation. So, and velocity of the particle of doing SHM is omega square root a square minus y square. So maximum velocity is given by Vmax. Vmax is given when y becomes 0. So maximum velocity is omega a. So first of all, check the third condition. Let us check the third condition. Root mean square velocity is 1 by root 2 times of its maximum velocity. So maximum velocity is omega a. Root mean square velocity is the square root of here root mean square velocity is a square root of average of velocity square. So Vrms, this is root mean square is Vrms. Vrms is a square root of average of V square. Okay. Velocity is given by V equals to omega square root of a square minus y square. Omega square root of a square minus, let us substitute y equals to a cos omega t. So that becomes a square cos square omega t. Omega a square can be taken outside. 1 minus cos square omega t. That become omega a. 1 minus cos square omega t is sin square omega t and can be taken outside of a square root. So that will become omega a sin omega t. So this is the velocity in terms of sine function. So a square of the velocity we can take average of a square of velocity. Average of velocity square is average of velocity square is average of V square. V square will become omega square a square sin square omega t. Omega square a square average of sin square omega t, omega square s square. Average of sin square omega t is 1 by 2. So omega square a square by 2. So this is the average of a square, average of velocity a square. So Vrms will be a square root of average of V square. So we can write a square root of average of V square from equation 1. Substitute V square from equation 1. So that will become omega square a square divided by 2. So omega a can be taken outside of the square root. So this is omega a divided by square root 2. Omega a is the maximum velocity, V maximum divided by root 2. So the the statement third, root mean square velocity is 1 by root 2 times its maximum velocity. So third statement is correct. Now let us verify the second statement, maximum kinetic energy. Average kinetic energy per cycle is equal to half of its maximum kinetic energy. Let us check the second statement. For kinetic energy is given by half of mv square. Half m velocity square is given omega square a square minus y square. Half of m omega square a square. We can substitute y equals to a cos omega t, a square cos square omega t. Half of m omega square, a square can be taken outside. So 1 minus cos square omega t is sin square omega t. This is the kinetic energy. So we can take the average kinetic energy. So average kinetic energy can be written as average kinetic energy is given by integral of 0 to t kinetic energy dt divided by 0 to t dt. So it can be written 0 to t kinetic energy expression is half of m from equation 2. Write the kinetic energy expression from equation 2. Half of m omega square a square sin square omega t dt divided by 0 to t dt, and 0 to t dt will become t. So average kinetic energy will be 1 by t. This is 1 by t. We can take constant term outside the integration. So constant terms are half m omega square half m omega square a square integral 0 to t sin square omega t dt. Now evaluate this integration. 1 by t half of m omega square a square sin square can be written as, using trigonometric equation we can write 1 minus cos 2 omega t divided by 2 dt. Again we can write 1 by t half of m omega square a square, 1 by 2 can be taken outside, 0 to t 1 minus cos 2 omega t dt. 1 by t m omega square a square 1 by 2. First term will be calculated as t. Integration of 1 dt will become t minus integration from 0 to t cos 2 omega t dt. Cos 2 omega t will become sin 2 omega t divided by 2 omega. Limit of integration 0 to t. 1 by 2 m omega square a square 1 by 2 t minus, we can substitute omega equals to 2 pi by t. We can write 2 omega t and substitute t equals to capital T. So we will write 2 omega capital T. 2 omega is 2 pi by capital T into t. So t will be cancelled out. That will become 4 pi. So this will become sin 4 pi minus sin 0. So sin 4 pi will become 0 and minus 0. So that will become t by 2. This t can be cancelled out. So here we can write 1 by 4 m omega square a square. This is the average kinetic energy. This is the average kinetic energy. Now here given that average kinetic energy per cycle, average kinetic energy equal to half of its maximum kinetic energy. So maximum kinetic energy is half mv square. V square equals to omega square. So maximum kinetic energy is 1/2 m omega square a square. This is the maximum kinetic energy, and average kinetic energy we calculated. Average kinetic energy is 1 by 4 m omega square a square. So average kinetic energy is half of its maximum kinetic energy. We can write half of 1 by 2 m omega square a square. So this half m omega square a square is kinetic energy, maximum kinetic energy. So half of kinetic energy maximum. So average kinetic energy is half of maximum kinetic energy. So this statement is also true. Average total energy per cycle is equals to maximum kinetic energy. For first statement, total kinetic energy. Total kinetic energy is half of m omega square a square cos square omega t. This is the total kinetic energy. So average of total kinetic energy, average of total energy. This is the average of total energy. E total. Average of total energy is half of m omega square a square average of cos square omega t. Half of m omega square a square, and average of cos square omega t is again 1 by 2. So this will become 1 by 2 of half of m omega square a square. Maximum kinetic energy we calculated here. Maximum kinetic energy is half of m omega square a square. So this is the maximum kinetic energy. We can write half of kinetic energy maximum average total energy. So all the three statements are correct. So what will be the right answer? Option 4. All are true. All the statements are correct. So this is the correct answer to this question. Hope you found the solution understandable. Thank you.